Hey, what up, Christo? It's Hire. I was just gonna put something together for you that I know you don't have time, so I thought I'd throw it together for you because I'm just kind of doing nothing here anyway. So I'll show you how I would do it, and then you can kind of make it your own. So just looking at them, it looks like you've got a whole bunch of just fractions you're adding together, although they have polynomials in them. So one of the things I like to start with is like just kind of a review of how to add and subtract fractions. So like I'll take something like 1/2 plus 1/5, and then you usually just kind of start and you go, okay, well, we have to find a common denominator. We can't add or subtract them unless we have a common denominator. And most people will come to the conclusion that it's like, oh yeah, the common denominator for 2 and 5 would be 10. And so what you can look at is that for these to be common in this case, this guy would need a 2 over here, and this guy would need a 5 over there. So we're going to go that this one right here would be multiplied by 5 on top and bottom, and this one right here would be multiplied by 2 on top and bottom, and we get 5/10, which is the same as 1/2, and then we get 2/10, which is the same as 1/5, and then we're able to add them together because they have the same denominator, thus giving us 7/10. So that's kind of like my review that I start with, because each side, each of those denominators is missing something, and that's the same principle I use when I'm going to show the polynomials here. Okay, so here's your first one that was on there. It was 4x minus 5 over 3x plus 1. Sorry, I'm looking at a small screen here. Plus x plus 4 and 3x plus 1. So here we have the same denominator, so we're great. We have our common denominator. There's nothing that really needs to be changed. We're just actually going to add them together. And this is where I remind the students that I go, okay, well, I know my denominator. It's 3x plus 1 because they're the same. So I'm going to do 4x minus 5 plus x plus 4, in which case we're looking for like terms that we can add together. So we get 4x plus x. Those two are both x's. They are of the same power, so I can add them. So we get 4x. Where did my undo button go? Here we go. We get 4x plus x would be 5x. If they struggle with that, I usually use this little thing where I go, well, look, if you had 4 apples plus 1 apple, I would have 5 apples. And then we go, our other one is, sorry, I'm using a new program here, -5 plus 4, which would be -1. So what we got here is 5x minus 1 over 3x plus 1. And then we look to see if anything cancels. In this case, a lot of people want to cancel the x's, but we can't unless that x is a factor of everything up there. And only the first term there has that x in it, so we can't factor it out. Okay, for B, I'm going to try to do this one pretty quickly because this one's just for you, so you can kind of teach it your own way there. So we get 2x plus 7, and man, I can't see, let's see, x squared plus 2x minus 15 minus x plus 10 over x squared plus 2x minus 15. This is great news. They have the same denominator. Fantastic. That means that over here, it's going to have the same denominator as well. Two things with the same denominator, they're going to keep the same denominator. No changes need to be made. However, on the top, we've got this 2x plus 7, and we're subtracting x minus 10. What most people want to do is they only want to subtract the x. We have to remember that you got to subtract both. We have to subtract an x, and we have to subtract a 10. So it really looks like this, 2x plus 7 minus x minus 10. In which case, combined like terms, we get 2x minus x is x, positive 7 minus 10 is -3. So what we're left with is x minus 3 over x squared plus 2x minus 15. What we have to be careful with this is when we see quadratics in the denominator, when something is to the second power, it might be able to be factored. And if something can be factored, then it's a possibility that something will get canceled out. So we have an x minus 3 on top, and we're going to factor this, or at least try to factor it. And we're looking for two numbers that multiply to give me -15, that when added will give me +2. So the numbers I'm going to try are -3 and +5, because -3 times +5 is a -15, and -3 plus 5 is that +2 we're looking for. So these are the guys we're looking for. So we get here, and I go, oh, look, bro, I got on the top, I have an x minus 3, and on the bottom, I have an x minus 3. They're both being multiplied, so I can get rid of them, cancel them out. What I'm left with is 1 over x plus 5. Done and done. Okay, C is 7 over x plus 2 plus 3 over 2x plus 4. They do not have the same denominator, and this is where we run into that original example of like 1/2 plus, I don't know what I said, 1/5, that they had different denominators. So I'm looking for what is it that they both need to be the same. And there's not really much I can do with this x plus 2. It's just an x plus 2. They don't have anything in common with each other. But what's more interesting is over here, this guy over there, the 2x plus 2. Just because we notice they have something in common, what we can try doing is factoring out of 2, dividing both those things by 2, and what we would have left over is 2 times x plus 2, meaning that this thing right here is exactly the same as that. There's no difference. So if I were to rewrite this, I've got 7 over x plus 2 plus 3 over 2 times x plus 2. Now, if you look at the denominator, these denominators are almost the same, except for this guy's got a 2 and this guy does not have a 2. So to even everything out and go, hey, we need this to be the same, what I'm going to do is I am going to put a 2 in the denominator over here, but I can't just throw it in the denominator. Like, I got to do, whatever I do to the top, I have to do the bottom as well. So I'm going to multiply that by 2 as well, in which case I get 14 on the top here. So this guy's a 14. We'll just keep that in mind. Now we know that our denominator, that is the same, our common denominator is going to be 2 times x plus 2. On top, we have a 14, that 2 times 7 is 14, plus 3. 14 plus 3 is going to give me 17. That 17 is not going to cancel with the 2. The 17 is not going to cancel with the 2x plus 2. Some teachers like to see them factored, but in this case, it doesn't really factor out. If we wanted to, we can work that back out and say this is 2x plus 4, because there's nothing that's going to cancel out there. So now I don't know if they want us to list any restrictions. In this case, we've got, I don't know if on the others we did as well, but actually for all of these, one of the things is that we have to list what x cannot equal. Like if they ask you about any restrictions, one thing you're never allowed to do is you're never allowed to have a 0 in the denominator, because that means divide by 0, and that's not possible. You can never divide by 0. So what we're looking at is we go, well, what would make this broken? So like how, if that ended up as 0, it's going to be broken. So where is it that 2x plus 4 equals 0? So we solve that algebraically. We move the 4 to the other side by subtracting 4, and we get 2x equals negative 4. We divide by 2, divide by 2, and we get x equals negative 2. So it's not that x equals negative 2, but if x did equal negative 2, that bottom would end up as 0 and the whole world would blow up. So that's not good. So we'll just say x cannot equal negative 2. So that's the restriction there. We know that if we were to, where's it adding? Yeah, if we were adding together, we would get 17 over 2x plus 4. However, we might want to note that x is not allowed to equal negative 2. Okay, so for D, we've got 7 over 2x plus 3 minus 3 over x plus 5. Now we have the situation where these two things do not match. We go, these are not the same denominators. I see that the one on the right has an x plus 5. The one on the left has a 2x plus 3. So for them to be the same, they both have to have exactly the same thing in there. Well, the guy on the left has 2x plus 3. The guy on the right has x plus 5. We need to make them the same. So over here, we're going to need an x plus 5. And over here, we're going to need 2x plus 3. Now, we can't just do that. You're not just allowed to just throw one in the bottom there, but you can as long as you throw it on top too. That way we're really, the secret is, the reason we can do that is because we're only multiplying by 1, because it's okay, 2x plus 3 over 2x plus 3, we're just multiplying by 1. X plus 5 over x plus 5, just multiplying by 1. They now have the same denominator, so I'm just going to write that off to the side here. It's like, I know that the denominator is going to be x plus 5 times 2x plus 3. Now, maybe we'll end up doing something with that. I don't know. We're going to see where this goes. Over here, I'm going to distribute. We've got 7 times x and 7 times 5. 7x plus 35. Over here, we've got 3 times 2x and 3 times 3. That becomes 6x plus 9. Now, it told us to subtract them, and remember, we have to subtract both of them. You can't just subtract one, so we're going to subtract that, then subtract that. So 7x minus 6x would just be x, and 35 minus 9 would give me positive 26. So what we end up here was with a positive 26. Now, I don't see anything in the top and bottom that's matching there. There's really not anything that can be factored out. So really the most proper way is, the one thing that we're gonna have to do is, I see it's factored, nothing cancels out there. I am going to have to combine the bottom. So usually I'm gonna have to combine them and go, okay, well, let me see what this all would work out to. But before I get there, it's actually super easy to go, well, wait, before I do that, let's address what cannot be 0. Now, there's two things in the denominator being multiplied together, and we have to remember that if you are, like, let's say you want your, like, let's say you multiply two things together, whatever they are, you're just going to multiply two things together and they equal 0. I know one thing to be true: either one of those numbers is 0 or both of them are 0. So it means that either, if this is going to end up as 0 in the denominator, either this will equal 0 or this will equal 0, or both. So that's how I'm going to find those limitations right there. Is I'm going to go, oh, okay, well, which one of them equals 0? What would make x plus 5 equals 0? And I would go, okay, subtract 5 from both sides, and we end up with x is equal to -5. So x is not allowed to equal -5, because if it did, the bottom would be 0 and the universe would explode. Over here, we go 2x plus 3 is equal to 0. That's not allowed to equal 0, because if it did, again, the universe totally explodes. Here we go, 2x is equal to -3, divide by 2, divide by 2. X is totally not allowed to equal -3/2. So those are our restrictions there. Last but not least, nothing we can do at the top, nothing to be multiplied. That's just like that. To multiply the bottom out, we have to FOIL. So again, FOIL stands for first, outer, inner, last. The way I like to do it is, I always tell my students, if they have trouble with this part, is we're very fortunate that we live in Florida, because I write Florida on top of both of them. And that tells me which are the first terms in each and the last terms in each of them. And I go, well, look, if these were 4 friends standing together, these two right here are on the outside, and these two right here are on the inside. So now when I do FOIL, F times F, O times O, I times I, L times L, I'm going to do this pretty quickly here, but you get the idea, because it really is for you, not for the student, so you can show them. So x, so I'm looking at my f's, f times f, that would be x times 2x, which would be 2x squared. Looking at my o's, o is x times 3, which would be 3x. I times I, which is 5 times 2x, which is 10x. Last but not least, L times L is 5 times 3, which is 15. Now, we would be able to say we're done, except for there's still things that can be combined right here. Forgive my sloppy handwriting. It's late. 2x squared. 10x plus 3x is 13x plus 15. Nothing to be canceled out, and we're done. And let's not forget, when we do our answers, that we do have these restrictions. We need to make sure we indicate that, because the x is not allowed to answer. No, excuse me, x is not allowed to be those things. Okay, 2 more and we're done. Hopefully you're watching this like high speed, so I'll try not to be too boring here. Okay, so we've got x plus 3 over x squared minus x minus 2 plus x over x minus 2. Now those denominators look totally different, and I would be like, I might look at them and go, well, this guy needs an x minus 2 over here, and this guy needs an x squared minus x minus 2 over there. But the truth is, I might be able to get away with a little bit less here. So here's what I'm going to do is, hopefully that showed up in the recording. If not, that's okay. X squared minus x minus 2. The first thing I'm going to do whenever I see quadratics here is I'm going to see whether I can factor them, because maybe there's something hidden in there. So I'm going to go, okay, well, quadratics can be factored. I'm looking for 2 things that equal -2 when multiplied, but equal a -1 when added. So if I think about that, I go, well, wait a minute, -2 times +1 when multiplied would give me -2, and when added would give me a -1. So it looks like those are the things I want. Well, now if I go, hey, this is exactly the same as that. You know, it's like saying $50. You can say I have $50 or I have $25 and $25. Same thing. So these are the same things right there. So I go, okay, the guy on the right has an x minus 2. The guy on the left has an x minus 2 and an x plus 1. So actually the one on the left is fine. It's the one on the right who needs something, and he needs an x plus 1 on top and bottom. Now they have a common denominator, and that common denominator is x minus 2 times x plus 1 On the top, so that's our common denominator. On top, we've got an x plus 3. That's not going to change because we didn't change anything on the left. However, on the right, we've got an x times x, which would be x squared. We've got an x times 1, which would be x. When I'm done with all this, this will be, well, x squared has nothing to be combined with. X and x are 2x, and then there is a positive 3. So we get x squared plus 2x plus 3. And this is usually the point where we go, well, hey, is there anything on the top and bottom that will cancel out with each other? And that's where we go, okay, well, let's look. And so what I'm thinking in my head here is I go, well, are there two numbers that could multiply to give me positive 3 that would also add to give me a positive 2? Well, if you think about it, the only thing I'm going to get a positive 3, I could do positive 3 times positive 1. That would give me a positive 3, but they won't add to 2. I could do negative 3 times negative 1, but they won't add to positive 2. So nothing is going to factor here. This is not going to factor into whole numbers there. So we're going to leave it alone there. We're going to say, okay, well, that's not going to factor. It's not going to end up canceling out with anything. So we're just going to leave it as x squared plus 2x plus 3. And in the bottom, we still have our x minus 2 times x plus 1. And the only reason we're not working that out yet is because, remember, restrictions. We want to make sure we identify that x minus 2 could equal 0 and destroy the universe, or x plus 1 could equal 0 and destroy the universe. X equals 2, x equals negative 1. These are two things that x is not allowed to be, or the universe goes away. Here we go, x squared plus 2x plus 3. All I'm going to do is work out the bottom now. Foiling it. I'm going to write that floor. I'm not actually doing it, but if I were teaching, I would write floor on top. Who are the outer guys? Who are the inner guys? And what we would have is x squared plus 1x minus 2x minus 2, which will then be combined. X squared plus 2x plus 3. In this case, this would be a negative x. Positive 1 minus 2 is a negative 1x, or x squared minus x minus 2. So those two aren't going to cancel out with each other, so we are done our final answer with our restrictions. And I think we just have one more problem, and then we'll be done with it. Okay, last but not least, we've got x over x squared minus 4 minus 10x over x minus 2. So we've got these two things in the denominator, and one of them that we got to start looking out for is this x squared minus 4. This is a really unique thing because what we've got is two square numbers. X squared is a square because x times x is x squared. 4 is a square because 2 times 2 is 4. And since it's subtraction, that is the difference of two squares. And the way that difference of two squares rule works is that that can be factored into two things. And difference of two squares will always factor into one of them being a positive and one of them being a minus. So, or a negative, sorry. The x squared, I'm going to split it up. So since there's an x squared as the first one, I'm going to put one of the x's here and one of the x's there. There's a 4, so remember 2 times 2 is 4, so 2 and 2. So that is the difference of two squares. It is factored there. Minus 10x over x minus 2. And we look at it, the denominators are now closer to where they should be, but the guy on the right is missing an x plus 2. So I'm just going to give him an x plus 2, but then I have to give the top an x plus 2 as well. So we know our denominator is x minus 2 times x plus 2. And on top, we've got an x minus, and here we've got a 10x times x, which would be 10x squared, and a 10x times 2, which would be a positive 20x. Now remember that both of those things are being subtracted, so we get x minus 10x squared minus 20x. We are quickly approaching the finish line here. We've got x minus 10x squared minus 20x. All I need to look out for here is I go, hey, look, I've got an x and a negative 20x. They are both to the same power. It's x to the first power on the left, x to the first power on the right. If I've got 1 of something minus 20 of something, that would leave me with negative 19 of that something, x. And so negative 19x minus 10x squared over x minus 2, x plus 2. We have to remember restrictions here. X minus 2 is not allowed to equal 0. X plus 2 is not allowed to equal 0. So x is not allowed to equal 2, and x is not allowed to equal negative 2. Those are our two restrictions here. We could leave the answer like that, but we do kind of like to, sometimes people like to see those numbers as positive numbers. There's nothing wrong with this. There's a couple different ways that teachers sometimes like to see them. First of all, they might like to see the highest power first, which is usually you write your highest powers first. So we've got a negative 10x minus 19x. And then this might be one way, x minus 2 x plus 2. So that might be one way to write our final answer. Sometimes they don't want them to have like both of them have negatives out there. So what we can do is we can factor out a -1. We're actually just going to pull that negative out, kind of like this. We're going to pull that negative out, and what would be left is a 10x squared inside and a positive 19x. Like if you think about it, we just pulled that negative out. If we put it back in, it would be back to a negative 10x and back to a negative 19x squared. So that's where that's coming from there. I'm just going to clean this up here in one more step, and then we'll be done. So same thing as above. I'm just going to write it like this just to make it look cleaner. 10x squared plus 19x, meaning that that negative goes with everything on the top. And now that x minus 2, x plus 2, I can just recombine it if I want to x squared minus 4. That's still the difference of two squares, but since it doesn't cancel out, we don't need to leave it separated. This just looks much cleaner. Done and done. Don't forget about our restrictions. And that is it, buddy. I hope that helps. Bye.